In this video, we will go over worksheet 8-9. It is the master review worksheet on the quadratic formula and the discriminant. In the first half of the video, we'll just apply the quadratic formula, and in the second half, we'll explain what the discriminant is. But just for a short preview here, the discriminant is this part of the quadratic formula. Now, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We'll go over one quick example here that's on the worksheet that you have. It says solve 2x squared minus 5x minus 12 equal to 0 using the quadratic formula. We first identify the a value, the b value, and the c value, which we already have defined for us right here. We just apply these into the quadratic formula. And we apply it in here. Keep in mind a negative 5 will become a plus 5. The negative 5 squared, of course, will be the 25. And a negative times a negative will give us the positive. And 8 times 12 is 96. We're going to have 25 plus 96 all over 2 times a. If we look at the sheet over here, we actually did some of the work here. We have the 5 here, the 25, and the 96. And a negative makes it a positive. 25 plus 96 is 121, which we have written right here. And we can take the square root of 121, and it comes out to a nice number. That's the integer 11. So we have two solutions. We have 5 plus, I shouldn't circle, we have 5 plus 11 divided by 4, and we have 5 minus 11 divided by 4. And we get our two solutions here, x equals 4 or x equals minus 3/2. Now there's another video that also goes over the intro to the quadratic formula, and I hope you've watched that video before you watch this one, because we're going a little faster in this video. Now let's look at the first homework problem. Number 1. X squared plus 2x minus 35 equals 0. We first identify the a, the b, and the c value. A is 1, b is 2, c is negative 35. So we plug in the values here. It's a minus b for the quadratic formula, so it's minus 2 plus or minus b squared minus 4ac. 1 times a negative 35. All over 2a, and a is 1. Now we're going to simplify it below. So we still get minus 2 plus or minus the square root. No, 2 squared is 4. A negative 4 times 1 times negative 35 becomes a positive 140 all over 2 times 1. So this becomes minus 2 plus or minus the square root of 144 all over 2. The square root of 144 is 12. So we get minus 2 plus or minus 12 all over 2. And we get our two solutions. We get minus 2 plus 12 divided by 2, which is 10 over 2, or 5. And we also get minus 2 minus 12 over 2. That's minus 14 divided by 2, which is minus 7. So we get x equals 5 or x equals negative 7. Now let's look at number 2. We're going to first identify the a, b, and the c values. A is 3, b is 7, and c is 2. And we'll just plug them into the formula here. Here's negative b, so it's a minus 7, plus or minus b squared, minus 4ac, which is 3, 2, all over 2a, 2 times 3. Now we'll simplify it. We have minus 7, plus or minus the square root. 7 squared is 49, minus 4 times 3 times 2 is going to be 24, all over 2 times 3, which is 6. So we get minus 7 plus or minus the square root of 49 minus 24. Well, that would give us 25, all over 6. And we take the square root of 25, which is 5. Now, if we got values of square root of numbers that we could not take the square root of into a nice integer, we may have to use a calculator to get the actual values. And even then, we'll be rounding with our calculator. But that's okay, because if we're graphing problems, we don't want square roots in the answer. We want the decimal values as well. Here's our two solutions. We get x equals minus 7 plus 5 is minus 2. So it's minus 2 over 6, which reduces to minus 1/3. Or we're going to get x is equal to minus 7 minus 5, which is minus 12 over 6, which reduces to minus 2. So we have our two solutions. X equals minus 1/3 or x equals minus 2. Let's look at number 3. A equals 1, B equals 1, and C equals minus 20. Minus B, so we put a 1 here, plus or minus the square root of B squared, 1 squared, minus 4AC, all over 2A. So we'll simplify again. 1 squared is 1, minus 4 times 1 times minus 20 is a positive. And that becomes a positive 80 all over 2. And we can still combine like terms. So we got a square root of 81 over 2, which of course is 9. So we get minus 1 plus or minus 9 over 2. So we get our two solutions. Minus 1 plus 9 is 8. 8 divided by 2 is 4. Or x equals minus 1 minus 9 is minus 10. Minus 10 divided by 2 is minus 5. Let's go to number 4. A is 2, B is minus 9, C is minus 5. The quadratic formula is x equals negative b, so it's going to be a negative 9 this time, plus or minus b squared minus 4ac, all over 2a. Well, minus a minus 9 is a positive 9. Minus 9 squared is a positive 81. Minus 4 times 2 times minus 5 is a positive 40. All over 2 times 2, which is 4. We now get the square root of 121 when you add 81 plus 40, all over 4. And so we get 9 plus or minus 11 over 4. Now 9 plus 11, that is 20. 20 divided by 4 is 5. Now 9 minus 11 is minus 2 over 4. And then we can reduce this to minus 1/2. So we get our two solutions here. Now on the other page, we're going to discuss the discriminant. The discriminant is just part of the quadratic formula, which I'm going to write right here. The discriminant is this part inside the square root. Now, we know we can't take the square root of a negative number because it's an imaginary answer. But we can take the square root of 0, because that's 0, and the square root of a positive. We can get an answer, but sometimes it might be some sort of irrational, non-repeating decimal answer. Or it could come out to a nice whole number. What the discriminant tells us is whether the graph crosses the x-axis. So let me draw a couple graphs here. In the first case, when b squared minus 4ac was positive, whenever we got a square root, excuse me, let me fix that here. Whoops, let me go back up. Apologize for that. When b squared minus 4ac was greater than 0, we got a solution. We got a positive square root. And you could take the square root. You always got two solutions. So what happens is you end up getting a graph where it crosses the x-axis twice, like here and here. Whenever we get a square root of 0 inside the answer, inside the discriminant, what that is telling us is that we only get one solution. And the only way you get a quadratic gets one solution is when the intercept is actually on the x-axis. And it could be up or it could be down. It could also be down over here somewhere. It could be also be on the negative side. It could be on the left or right side. It doesn't matter. These are just one solutions. And no solution is when we have a quadratic and it never touches the x-axis. Like maybe it goes up here. This has no solutions. It never touches the x-axis. That's all that tells us. The quadratic still exists, and it's a good quadratic. It just does never, ever touch the x-axis. This becomes important even in some real-world situations. Sometimes there may be no solution for the equation we have, and that could mean many different things, including the equation is inaccurate, or it could also mean that the equation, if there's no solution, it means that there's no possible answer that could be solved. Maybe we're trying to find some sort of a maximum cost, and maybe the cost will forever keep increasing. Now here's an example using the discriminant. We have 4x squared minus x plus 5 equals 0. They identify the values, and they just, instead of using the whole quadratic formula, we just use the discriminant part, b squared minus 4ac. And they plugged in the b, the a, and the c, which they did right here, here, and here. And they got a negative answer. We got negative 16 when they did 64 minus 80. That tells us the graph does not cross the x-axis. So it's drawn either above or below the x-axis. So the original function here of 4x squared minus 8x plus 5, we know it's opening upward, and it doesn't cross the x-axis. Well, the graph, let's see, do we know the y-intercept? If you plug in 0, we get 0, 5, 1, 2, 3, 4, 5. So the graph crosses. So the graph looks probably something like this. It's an educated guess. We could even find the axis of symmetry if we had to, and then we could find the vertex. But the graph looks something like that. So we have a quadratic function. It just never touches the x-axis. Another example, a, b, and c. In this case, there's no x value. So we can think of it as 9x squared plus 0x minus 49 equal to 0. That's why the b value here is going to be 0. They still applied the formula, and they got a big positive answer here. You know, this would have been inside the square root, the discriminant. This would have been minus b plus or minus the square root of 1764 all over 2a, which is 2 times 4. And this b value here would have been 0. But we still get two answers because it's plus or minus a positive square root. So there are two real solutions. And that means the graph will cross the x-axis at 2 points. Now we're just going to apply the discriminant for the rest of the homework. 4x squared plus 20x plus 25. We're not asking for the solutions. We're just saying find the number of solutions. Okay. A is 4, B is 20, C is 25. So b squared would be 20 squared minus 4ac. 4 times 4 times 25. 20 squared is 400 minus 4 times 4 times 25. Well, 16 times 25 is 400. And we're going to get 0. 0 indicates we get one real solution. It'll cross the x-axis at one time. The vertex is actually on the x-axis. It's going to be on the x-axis somewhere. Now, you don't have to graph it. I just want you to kind of understand what this means. It will be on the x-axis. Next problem. A is 15, B is 8, C is negative 1. B squared is 8 squared minus 4AC. We get 64 minus 4 times 15 times minus 1 is a plus 60. So we're going to get a positive 124, which is greater than 0. So in this case, we will get two real solutions. This graph will cross the x-axis at 2 points. It will cross it at 2 points. Last two problems. Number 7. So we'll do b squared. So it's 9 squared minus 4 times 1 times minus 36. You get 81 minus 4 times 36, I believe is 144, but it'll be a positive 144. We add these together, we'll get 5. 8 plus 4 is 12, carry 1, we'll get 225, which is greater than 0. So we will get 2 real solutions. Last one. I'm going to rewrite this here because there's no b value. B is 0. So 0 squared minus 4ac. 0 minus 400, which of course equals minus 400, which is less than 0. So we can either write as no solution or 2 imaginary solutions. In your higher math, we're going to get into a lot into imaginary solutions, and they're going to be important because keep in mind, the graph does not cross the x-axis, but it could still have some interesting points. But that'll come later in geometry and again in Algebra 2 and Pre-Cal, when you worry about imaginary solutions. Well, that is it for this video. We just completed the worksheet.